Okay, so indoor mapping. So why are people doing indoor mapping? Well, we all have these nice mobile devices, and when we walk around outside, we know exactly where we are. We can find the nearest store and things like that. But the moment we go into buildings, often now it just becomes this big void, and we see ourselves in the middle of this big square box, and so indoor navigation is one of the big things. Also for organizations who are operating these facilities, when we think about airports, we often think that a good synonym is like they're like a small city. And so how do you manage all the spaces of the city? How do you manage all the infrastructure, which is called facilities? And that's another use of the indoor mapping. Okay. Interestingly enough, we spend 90% of our time indoors, and we've spent up till now, we've really spent most of our time mapping the out of doors. And so now with indoor mapping, we're starting to really map the indoors. And there's other things that are driving this, devices, IoT devices and things like that, the more, if we can map where those are, then we can increase our operational efficiency, but also learn about things. And also the mobile device, of course, is key to that, because now people can figure out exactly where they are, whereas in the past.
And where they want to go.
And where they want to go, that's right. Indoor mapping, here's some of the formats that are that we've worked with. Of course, there's many more, but native Revit reading, that's a big one. So we've added that in 2019.0. Yeah. So if you want to go that to indoor, that's much easier than CAD, would you say, Dave?
Pretty much everything's easier than CAD.
Okay.
So it's not a reflection on CAD itself, more on the type of maps that are made in CAD.
Yeah. And the variation on CAD is just massive. Yeah. I was at a conference where a guy mentioned that he had a CAD file with 20,000 layers. Ooh. And then another guy had a CAD file with 1 layer, which everything was put on the
that's actually worse.
Layer 0. So you can see now if you're going to paper, then the paper just has 1 layer, and so everything it can look great. So anyway, IBM Tririga is a facilities management system, and again, if you have the CAD integration piece there, a lot of the hard work for the floor plans has already been done. Yep. So we read those CAD files, and they're in great shape. And of course, the big indoor formats, OGC Indoor GML, IMDF, which is the Apple-backed format, Here Venue format. We also support SAP HANA, and ArcGIS Indoors. And you can tell by the arrows which ones we read and which ones we write. So there we go. Okay. So some of the challenges with indoor mapping is not the data format. So it's not a syntactic problem. If we look at IMDF, for example, it's a really nice GeoJSON format. And you look at it and you go, oh, this is really a nice format. The challenge is that the semantic models of these formats actually enforce the real world rules. So for example, you can't have a floor, if you have a building floor, with nothing in it. There's no building you walk into and all of a sudden you ask somebody, where did he go? Oh, he entered the no man's space and was kind of just disappeared. Everything is mapped. Also, you don't have any rooms that overlap each other. You don't have, I have an office, Dave has an office. There's no spot where I walk in my office and suddenly I'm in Dave's office, and, there's all the end floor, rooms can't be outside of levels can't be outside of the building footprint, and so on and so on. And so when you start codifying all these rules, it makes moving to the indoor format much more difficult. But of course, once you actually have this, let's call it a digital twin of the real world in IMDF, then now you can really start to make it supports better applications, which I'm sure are coming in the future.
Yeah.
Okay. Yeah. So indoor mapping, this is a new area, and of course it requires 2 things. It requires the floor plans, but it also requires who's using the space. So if you think about a shopping mall or an airport, and airports really are like shopping malls. I mean, I was just in Frankfurt, and man, it was like walking down Robson Street, and but it's important. So if they get the floor plan right, but they don't tell me where Stephanie's favorite store is, Cartier, then she's going to be lost, right? She knows Cartier's somewhere in that mall, but she doesn't know where it is. But so you have to also pull the usage information from the facilities management, or maybe it's the lease system, combine it together to have an indoor map that is actually useful. The obvious one at airports is where are the gates, right?
Exactly.
Yeah.
Yep.
So yeah, but you have to, and those are going to come from different systems, but that's okay. FME can read anything. And the other challenge is I can't remember the last time I was in an airport where they're not changing. Every single airport seems to be under construction. I left Frankfurt, it was under construction. I arrived in Vancouver, it's under construction. Everything is always under construction. And buildings are like that. And so you need a way to constantly, once you build your workflow, you need a way to automate that so you can constantly run it to update as the venues are changing. And so the idea with FME is we're going to hide the details so you can focus on just building the model and not worry about it. And we'll see a screenshot a little bit later on the IMDF validator that we show you. You do not ever need to understand it, but it gives you an idea of the complexity and the rules that you have to apply to this. Okay, so yeah, so with FME, it's really quite simple. You have to find your floor plans. Yep. And it could be CAD, they could be in other systems, and then you have to convert your floor plans into an indoor mapping format. Now you could decide to do that step first and then later add the lease information, or you could do it all at once. That's up to you, and there are pluses and minuses on both. When it comes to CAD, sometimes you're going to find CAD data that's so bad that it's really not.
No, it's yeah. Sometimes you just can't make it work with indoor, but there are tools in AutoCAD, and also the Esri's got a new product out, Esri Indoors, where they try to help you. And essentially, you're redigitizing the data. But that in some ways that's okay. It's almost some way faster to make a very simple floor plan data rather than trying to hammer all this complex CAD data that looks really pretty when you print it, but doesn't make any sense topologically. Sometimes you just got to go do sort of quick and dirty floor plan, make your polygons nice, because ultimately it's a question of scale, right? You're going to get this from distance. You're not zooming into like a corner from 3 feet away, right?
And that's a good example of where CAD data is being repurposed for indoor. CAD drawings were often made for building construction, and so they have an amazing amount of detail in them. When you're going to indoor, you do not care about how the rooms were constructed. It's irrelevant. You just want to know the spaces, where the doors are, where the halls are, and things like that. So and of course validation. We'll talk a little bit more about validation. And the nice thing with FME is you don't write code. You just simply use our visual environment.
That's true. Although if you really want to write code, we can make that happen.
That's true. If you really want to write code, you can. And in fact, I was at a world tour stop and somebody said to me, hey, the only transformer I need is a Python caller. And then they wrote everything in Python. So that's an extreme.
They probably don't want to tell their boss that.
No,
but,
no. So the way the workflow for indoor data is, you got to find all the data sets, and that often can be a big task. Just, okay, where is the source data that I need in order to build my indoor map? And then you got to prepare it for output. Then you validate it, and then, it didn't validate, so now you got to go back again, and maybe you got to prepare for output again and try again. But then, you might find that you're actually missing some data, and so then it's an iterative process until you actually get the data out to the output. And so with FME, yes, there's also this whole notion of georeferencing, which means moving the building to the correct locations. Like when I've looked at a CAD drawing, I've never seen the rooms and everything specified in lat-long coordinates for construction.
Generally on a local coordinate system, because everybody who's at the building knows where the building is.
That's right.
Because they're there.
That's right.
But when you're trying into locational services using GPS on your phone, the GPS knows where in the world you are, and it really wants to relate that to the map that you're seeing.
So the whole building, every single point needs to be removed and moved to a lat-long coordinate system. And so that has its own set of challenges. You might not know where the building is, but the nice thing for indoors, you don't have to be that accurate. You're not actually building the building. So we've had success just by going online and figuring
out where it is, doing a little angle calculations and
Yeah.
throwing in an offsetter or two.
Yeah. And then you can see the other ones there, and cleaning is just the data QA. So